Hello guys, welcome to S Academicus. So this is my second video on the introduction of substation to civil structural engineers. So in last video I have discussed the difference between flexible uh, conductor substation and rigid bus substation. So in this video I'll be explaining more about rigid bus substation and how to do the rigid bus analysis. So in the left hand side of my screen, you can see there is a plan. There is a plan of a substation, a small one, a 115 kV substation, and the on the right hand side of my screen, the elevation of that substation. So how exactly we are doing? I'll just talk about the analysis procedure. I will not go very deep into the modeling and analyzing the rigid bus. I'll just explain the concept behind that analysis. So is the plan. You can see these are the tube, the aluminum tube or copper tube, and these are the insulators. There are three phases. One, two, three. You can name it R, B, Y, the red, blue, yellow. Or the electrical guy will give you more in-depth knowledge about the phase of the bus. But I'll just say this is phase one, phase two, phase three. So these are three phases of a conductor. The conductor type is a tubular bus, which is a rigid bus, and these are the insulators. So we are actually going to model these insulators and the conductors, and we are going to uh, the analyze the rigid bus. So whenever you see this, there is a substation in a rigid bus. There are two types of bus based on the height of the bus, a rigid bus. So the first one is high bus, where the height of the bus is like at higher level, and the other one is low bus. So when there is a differentiation based on the height, we call it high bus and low bus. So in a substation, rigid bus substation, we have high bus and low bus. Now, the section of this, like A section, if you see in the section, you can see this. Uh, this these two supports, you can see one, two. This is the switch equipment. Switch is nothing but an isolator, or you can call it a disconnector. And this is a box bay. This box bay structure is mostly used in the US substations, where many equipments are mounted on the same structure. Like there are SSVT on this. There the rigid bus is also supported on this, and there are other like small transformers. So those things can be mounted on uh, the box bay structures. So the box bay, you can see here, there are so many equipments. There is a safety switch, and there are other equipments. Which the type of equipment we can discuss on later. So yeah, so this is the bus. This is the bus support structure. You can see this. The height of this bus support structure is like the how do we decide the height of the bus support structure? Everything in a substation design depends on the bus height. Bus height means for a particular kV level, there is a standard height of the bus to maintain the ground clearance, to maintain the clearance from the structure, like the live part of the structure. So everything is decided based on the height of the bus. So if the height of the bus is, let's say, it's 20 feet, so all the structure shall be designed keeping the 20 feet bus height. We can't violate the it. We can go more than 20 feet because the minimum criteria is 20 feet, but we can't go below 20. That means we cannot design for a 19 feet bus because there is a minimum ground clearance criteria based on which these bus heights are calculated. Okay. So yeah, so this is how we are doing. Like these are the insulators. So for a particular kV, there will be a type of insulators which is proposed, and then you have to check like whether it is sufficient in strength or not. If it is not sufficient in strength, we have to select the other insulator with more strength, cantilever strength, or maybe we can have a double insulator on a particular support. So this is how we decide what type of tube size, that depends on your kV, your current, the capacity of the substation, and then the insulator. So initially we just assume, let's say for 115 kV we can assume 4-inch dia tubular aluminum tube bus, and then some type of XYZ TR287 or 2 TR287P or 2 TR286. So these are TR287 to 86. These are type of insulators which you can get from the electrical. If you are working in an organization, definitely there will be an electrical guy who will be working on the electrical part, and then you will be the structural support. So yes, so once you get these details, like which are the available insulators and the bus size, and then you can model this entire bus. So in rigid bus analysis, we are just modeling this tube along with this insulator support. So I'll just open a RISA model. You can see this. So this is how, like, these are the supports. I'll just see, you can see, yeah. So yeah, these are the insulators which they are supporting these buses. So one, two. So yeah, so this is how we are modeling. We are modeling this insulator and we are modeling this bus. Now, the modeling is very easy, but the loading is a little bit complicated because it is not just the conventional loading. Conventional loading means the wind loading, the seismic loading, the dead load, the live load. Definitely, the dead load, there will be a dead load of this tube, the insulator that will be acting on the structure. There will be a live load. Let's say there is no live load, or there may be some maintenance load that you can count as a live load, and there will be obviously wind and seismic. So these are the conventional load. But apart from these conventional load, there is another type of load for a substation design, which is the short circuit force. Short circuit force is the lateral thrust which will act on these buses. Laterally, it will act. So whenever there is like violations, or whenever there is some electrical violations in the circuit, it will create a short circuit force which is very like huge, but it will act for a fraction of second. So we have to design these rigid bus for the short circuit force. The calculation of short circuit force, I'll come up with a separate video on that. Maybe I'll just explain how exactly the short circuit force is being calculated. And then, yeah, then application of those short circuit force and on the structures. So basically, like, apart from the conventional load, there is a separate load which is the most critical, you can say, the short circuit force combined with other forces, like we do the load combinations for our conventional. So this short circuit force is also combined with the other conventional loads, and then we can have the worst loading combinations, and then based on those loading combinations we check these insulator and bus for strength, and then after that we just use the reaction which is derived from this rigid bus analysis to design these support structures. You can just mark it, like, these support structures are designed based on the reactions coming from these support structure can be designed based on the reactions from the rigid bus analysis. So yeah, this was just a brief introduction about the rigid bus analysis, how it is what is the logic behind it. And then there is like a bus support. You can say I have marked here high bus, and there is a bus support. Whenever this is a low bus, there whenever there is substation, if you see this is a box based structure. So at the box based structure, this side of the structure face, the bus height is less. So this is a low bus line or bay, you can say. This is a low bus bay, and this is a high bus bay. So whenever there is a high bus bay, the structure height is increased, and whenever there is a low bus height, so the structure height is reduced. So based on the height of the bus, we are designing two types of structures for rigid for supporting the bus. The first is yeah. So based on the height of the bus, there are two types of bus support structure: high bus support structure and low bus support structure. So yeah, so this rigid bus analysis, I just this is a brief introduction. This later I will be coming with stepwise analysis, load calculations, and then like how exactly we are designing these bus support structure. Those and I'll be sharing some few drawings also of these bus support structures, how we are doing that. So that will be taken in a separate video because I can't make a long video for 1.5 hours or 2 hours. So that will be just like boring. So I'll just make short videos on each topic, and then eventually I'll cover this entire substation civil structural design. Hope you have understood something about rigid bus analysis from this video. Like how at least you must have understood like why the rigid bus analysis is required in a substation design, and then later on we can just go in depth of the actual design, the structural design of rigid bus and the bus support structures. Thank you, have a nice day, and take care.